Dear student, today's topic is deviation through a prism of small angle. Suppose this is a prism of small angle prism. If it is the incident ray, this is the refracted ray, this is the emergent ray. You know this. Here we draw a normal. Here we draw also a normal. This is angle I. This is R1. This angle E. This is R2. ABC is the principal section of the prism. For small angular prism, we know that this is the angle deviation. This deviation, you know this. Suppose light is incident on a small angular prism. This is angle of I. This is angle of incident. This is angle of emergent. These R1 and R2 are here. The angle R1, E1 and R2 are also small because this is a small angular prism. Suppose mu is the refractive index of the prism, then according to Snell's law, mu is equal to sin I. यहाँ मैं देखूँगा sin I divided by sin R1. Here R नहीं, ये R1 है, sin R1. We can write I divided by R1 because it is a small angular prism, because angles are small. When angles are small, sine of small angle is also there. Suppose sine 0 is equal to 0. When angles are small, sine 0 is equal to 0. That means sine I is equal to I. Sine R1 is equal to R1. When angles are very small, sine I is equal to I. Sine R1 is equal to R1. Ultimately, we get here I is equal to mu R1. Here, I is equal to mu R1. Similarly, when we move in this, similarly I get E is equal to mu R2. Here in this case, E is equal to mu R2. And we proceed in the same direction, mu is equal to R2. We know that angle I plus E is equal to A plus D deviation. You already meaning I plus E is equal to A plus D. Or we can write say A deviation is equal to I plus E minus A angle of deviation. Okay. But instead of I can write this for small angle. I can write mu R1 plus instead of E I can write mu R2 minus A minus A. Mu इसमें कॉमन है, आप देखो यहाँ mu इसमें भी deviation is equal to mu R1 plus R2 minus A. ठीक है. But we are discussed in the previous classes this R1 plus R2 is equal to angle A, angle prism. Therefore, I can write, but R1 plus R2 is equal to angle A. I can write deviation is equal to mu A minus A. A में common निकालूंगा. Deviation is equal to mu minus 1 into A. This is the small angular prism. The deviation produced by small angular prism depends upon the angle of prism and refracting index of the material. Thus, the deviation produced by small angle prism depends upon the refracting index and the angle of prism. I will repeat this. This is 2-3 marks question asked in the examination. Deviation through a prism of small angle. If this is a small angle prism, that we know that this angle of incident, this is refracted ray, this is emergent ray, this angle I, this is R1, this angle E, this is R2. We have discussed in the previous class also. Here we know that refracting index is equal to mu is equal to sin I divided by R1. Here I took R, here is R1. Or for small angle this prism, sin I is equal to I, sin R1 is equal to R. Ultimately I get I is equal to mu R1. Similarly, I can give here E is equal to mu R2. But we have derived this formula I plus E is equal to A plus delta. A plus delta means deviation. Deviation is equal to I plus E minus A. Instead of I can write mu R1 plus mu R2 minus A. Mu is equal to R1 plus R2 minus A. But R1 plus R2 is equal to A. I can make deviation is equal to mu minus A into mu minus 1 into A. Thus the deviation produced by small angular prism depends upon the refracting angle and the angle of prism. If you take here a numerical here, this is a small numerical, sometimes asked here regarding this Here I will take two numericals, this small. Calculate the deviation. Calculate the deviation produced by prism of angle 60 degree. When it is a 60 degree angle, that it is small angular prism of refractive index of material of prism is given. That means calculate the deviation. We have to calculate the deviation produced by a prism of angle 60 degree. When angle of prism is called, that means given is here, a is equal to given, a is equal to angle of prism is equal to 60 degree. The refractive index is also given 1.644. That means here it is small angular prism. Then it is small angular prism, we have to produce the deviation produced by small angular prism is equal to delta is, deviation is equal to mu minus 1 into a deviation mu it is given 1.644 minus 1 into a 6 degree. If I this one message equal 0.644 multiplied by 6 degree, ultimately we get 3.864. This is the deviation degree. Deviation produced kitna hoga 3.864. I hope you have got it. Calculate the deviation produced by prism of angle 60. That means angle of prism is equal to 60 degree. That means it's small angular prism. It is refractive index is also given. We have to apply this formula. Deviation is equal to mu minus a1 a into a. That means 1.644 minus 1 is 0.644 multiplied by 6. Ultimately we can multiply these two, we can get it. One more numerical which is dependent on this. I can give a prism of 6 degree. That means again angle of prism is given 6 degree. Here gives a deviation of already deviation is 3 degree. What is the mu? What is the mu? Refracting index. That means we have given here angle a thin prism of 6 degree. That means a is given, a is equal to 6 degree, and gives deviation. Deviation is also given. Deviation is 3 degree. 3 degree. We have to calculate the refractive index mu of the prism. That means angle of prism is given. It is the minimum deviation. It is a small angular prism. Why? Because angle of prism is only 6 degree. Deviation is 3 degree. We have to calculate the refractive index. We know the refractive index is equal to mu minus 1 into a. That means ultimately we can get d. What is d? Is 3 into mu minus 1 into 6. Ultimately we can get mu minus 1 is equal to 3 by 6. 3 by 6 is equal to 1 by 2. 1 by 2. 1 by 2 is equal to 0.5. 0.5. Mu is equal to यहाँ आ जाएगा 0.5 plus 1 is equal to 1.5. That means its refractive index is 1.5. I hope you have got it. This is small. This was a small topic based on small angular prism, and it is sometimes is asked 2 marks question, and sometimes numericals are asked in this regarding this small angular prism. I hope you have got it. Thank you. We will meet in the next class. Thank you very much.